Hey, what's up everyone? Welcome to the stream. So a couple nights ago I was working on my debugger here, and what I got working was the display of local variables as long as they're of type int, and having them be displayed here. So let me just show that off a little bit here just to start off the stream. So if I hit F5 to start the debugger, you'll see it launches Vectrex, which is my emulator. Let me just attach to that. There we go. So here we are at main. It says locals, but there are none yet. Come in, and let's say I step here, I hit a breakpoint. Already we can see a bunch of local variables. These are variables that are currently in scope. So we can see that from the outer scope we have A and B. We have C from this scope here, and now we are inside this scope and we have E. We don't have D because that's not in scope right now. And I can also climb back up to main. Right now in main we have no variables in scope, but we do back inside the bar function. So if I step out of bar and I'm back in main, now I'm inside a scope that has variables. We can see X, Y, there's W that comes from down here, uninitialized values in them. F10, F10, you can see that those two change from 2, 0, and 1. I'm about to step into bar. So here I am, I've got A, B, C, and if I click back on main, we've got our X, Y, and W, just as before. So pretty much what I had working last time, looking pretty good. There was one small thing I wanted to try, because in this case, integers actually are they're characters, they're a type char. So I just wanted to show what would happen. Let's say I set this to be 126, and we increment B a couple times. So let's try that. We'll build. Not sure what's happening. Oh, okay, nothing. And then hit F5. Okay, there we go. So, oh, whoops, I missed my chance there. Let me put a breakpoint here. Let's hit it there. Okay, here we go. So B, 126, 127. And 128, 129. Did I treat it as an unsigned? Is that why this is happening? Let me take a look. This is what I wanted to validate. I don't think I'm doing it quite properly when I'm getting its value. Yeah, it's right here in front of me. Right, yeah. Yeah, that's not quite right. Casting it to an int here. So let's do that. So that ought to fix that problem right now. Did it build? Still building, okay. All right. One thing I'd like to do is to avoid this always having to attach thing. I was thinking of doing something where I show a dialog when I'm waiting for attachment, and then I could like skip it or ignore or whatever. All right, so let's see here. Here we are. B is 126, 127, and minus 128. That's much more what I was expecting, for it to act like basically a signed char. See, it says that it's an int, but int we compile with an option that says integers should be treated as 8-bit values. So that's why that's how it should behave. Okay, so that's cool. We have that working. The goal today is for me to start working on adding much more than just integer. We need to start adding a bunch of data type support, all these primitive types, signed, unsigned, longs, char, voids, all these things. So once I can get that going, then I can move on to pointers and references, and then we can go to aggregate types, arrays, structs. So yeah, quite a lot to do. Yes. There was one thing, I was talking to my colleague, the person who wrote CPP DAP today, about this problem I have where I've shown this already on stream a couple times, where if I launch our debugger here, I was telling him how, like, if I write anything in the watch window, I get this crash. And he looked a little bit quickly at it and he told me that he knows why. One thing he said is most likely what's happening is I'm getting an error, but I'm not handling the error, and then it's crashing because it doesn't really handle it gracefully. So that would be, let me just see here. Here, on error. If I put a breakpoint in there, and I do a watch. Yeah, see, there we go. Session error. So let's see what the message is. No request handler registered for command evaluate. So that's exactly what he was telling me, that there's, because I copied this code from the example that he puts with CPP DAP. I thought the sample covered all the, at least minimally required set of handlers. But there's a handler for the evaluate, which is what I guess watch is all about. Let me see if I can get that. Register handler. So there must be an evaluate request. Supports formatting. Oh, that's cool. So optional evaluatable name of this variable, which can be passed to the evaluate request to fetch the variable's value. Oh, that's cool. A lot to look into there, but yeah, here it is. Evaluates the given expression in the context of the topmost stack frame. Huh. Why does it have to be in the topmost stack frame, I wonder? I guess it means that it will only send it once. It doesn't matter if you keep changing on scope. The expression has access to any variables and arguments that are in scope. The context in which the evaluate request is run may be one of the following enumeration values: watch, REPL, hover. Huh. Wonder why that would matter. The expression to evaluate, I guess it depends. I guess if you want to format it differently for the different contexts, maybe. The expression to evaluate, right? So, because you can type anything you want, right, in the watch window. Yeah, that makes sense. And finally, the format, sure. So I think that's one of those things I saw earlier, which is like if you support formatting. So for example, putting like a maybe casting, maybe putting like comma S for string, comma H or comma X for hex or something like that. So here's an example. In fact, it looks like the only one is display the value in hex. So definitely we'll add that because that's pretty cool. Evaluate the expression and scope of this stack frame. If not specified, okay, so this is how that works. All right, they say here topmost stack frame, but really they just mean based on the frame ID. So yeah, not quite sure what that's about. But yeah, okay, so that's cool. So that would mean that for this, at least not to crash, we should handle that request and actually implement it at some point. So let's at least add it so that we don't crash. So we've got variables. Let's add it right under variables. I think that's a good spot for it. const dap, and it was called evaluate request. So we'll start with this. We'll do like this, yeah. And we've got probably a dap evaluate response. Yeah, so let's look at the response here. We've got indexed variables, memory reference, named variables, presentation hint, result, the result of the evaluated request, type, a whole bunch of stuff here. So yeah, this is definitely going to be a bit of work. I think just returning this for now, implement to support watch values. This at least will stop it from crashing. So let's give this a test here. Right. I was just thinking about a cheap and quick way we could do the attachment stuff. Like Windows has the simple like dialog box thing with an OK cancel. I think I can use that. That should be good enough. All right. So well, already we can see it's not crashing, right? So that's already. There you go. That's good. Like if I put a breakpoint in here. Oh, not long enough when it's optimized this way. But yeah, basically where we were crashing before, we can put whatever we want. Ultimately, of course, we would like it to actually do the thing. I thought erroneously that watch was just going to do this, like I thought watch would just take its values from whatever was in locals, but no, you really do need to implement it yourself, and that makes sense because you could put like expressions here. You know, you can do like a plus c, whatever. So definitely that's something to work on. Let me put a to-do for that. Actually, I have watch here, so I'll just put a little detail on what that means. So implement the, what's it called again? Evaluate request. Okay. Okay, good. Okay, so let's get to business. Now, this is the section that we'll be parsing. Currently, we already are parsing this. If we go take a look in the RST parser right now, this has gotten quite long. I definitely need to clean this up. It's way too long a function. But anyways, I don't want to like do it too early at the same time because I feel like if I do that now, I might paint myself into a corner. I sort of still want to see how this goes before I start refactoring it. All right. We are looking at data types. I have a hack here. So here it is, type definitions. So I'm looking definitely for the letter T, That's what all of these have here. I've got the type name and the type def ID, and I pretty much don't care right now about type definition ID, but I should care for doing this correctly. So type definition goes like this, one of these two. So there's a case where no range is provided, and then there's the case where a range is provided, and then the range might be given in terms of another type. One thing I notice about ranges is if it's given in terms of itself, that's one thing, but when it's given in terms of another type, it's always a type that was defined before and not afterwards, which is great because I don't have to, like, you know, do a second pass and collect types to resolve later, because I was wondering if I would have to do that, but I don't think so, right? Like here, maybe I'm wrong. See? This one, well, I don't really care about complex. I'm just probably going to skip those. But like R8 is of type 8, R9 is 9. These are self-referentials. These are not examples. Do I not have an R13, R14? Yeah, I don't have a single. So here I have here I have examples. Float is a range of type 7, and type 7 is int over here. Isn't that weird? That means that floats and doubles are treated like integers. I think that's what it means. I actually think that's what it means. That floats and doubles are no different from type int, except that they take more bytes to store. But I suppose they don't really. That doesn't make sense though. Doesn't make sense because I actually did some experimentation with the floating point type, and we saw that it did indeed store floats in memory, like with floating point values, with the mantissa, the exponent, the sign bit. So that's a bit strange. So is it more like saying, take a look at this data type for, I don't know what for. Very strange. It's a very strange, yeah, it's a strange definition for types. Because see, the idea is that it's supposed to be a type definition number that this is a range of. So like float is type 18 is a range of type 7, which is an int. Oh, what the hell? So yeah, I have multiple ways I can go about this, and one of them is to sort of ignore some of this information and like know the types myself, which, you know, sort of makes sense. But I would love for this to be a more generic parser that makes some sense out of this stuff. Like this makes sense, you know, like signed is a type 7. Yeah, that's confusing too. I thought that the T here would define a new type, but here 7 is already defined. Crazy. Oh look, I think we do have forward definitions over here. See, this is a range of type 7. Wow, what a mess. The docs on stabs about defining types actually say that this is really bad, like that it doesn't make a lot of sense. So I'm sure I'm not the only one who's looked at this before and has tried to like make sense of this, but it's crazy. Yeah, so the thing about the part 6 here, this is the lower bound of the range. So that's what we see here. Like over here, for example, well, let me take a better one. Here it's saying unsigned int is type number 10. It is a range of itself, which is awesome. And it ranges from 0 to 255. So here, because the lower bound is less than the upper bound, this is an actual range. This is the lowest value, the smallest value, and the largest value. And we can actually figure out its size based right there on the range type when it's provided. So that's good. There are cases, though, where the lower bound is greater than the upper bound. And typically, it's the lower bound is a value and the upper bound is 0. So, for example, these floating point types here, right? Double. So you can see that the lower bound is 4 and the upper bound is 0. In these cases, this represents the number of bytes that this type takes. So here, float, double are both 4 bytes. Long double is 4 bytes as well. And this has to do with the fact that this CPU won't support more than that. Or at least it means a compiler won't support it. I suppose it's possible to support larger data types if the compiler will do all the math with the stack and all that, but it doesn't. So this is basically a machine. It's a 16-bit machine, and it looks like it supports like double the 16 bits in terms of storage for math and stuff like that. So long unsigned int type 8. So this actually, that's a 32-bit value right there. So you can see that the maximal value we could support is 32 bits. That's a 16-bit. That's our 8-bit. Now that's our 32-bit again, 16-bit. These are signed values. Integer has nothing, so this is just we have to know. Char, okay, we've got the range here, so we can figure that out. That's going to be obviously 8 bits. Whoops. And then the signed alone is of type 7. So that's the weird one. I feel like what I have to do here is, what should I do? Should I have like an alternate name in that case? I don't like that we have 2 types with this, like 2 names for the same type. It should have been just 1. Because the idea then is later on when I'm looking up variables, I guess what I can do is I can ignore it. It doesn't really matter, right? Signed is the same as int. So if somebody writes signed, yeah, I think that's what we have to do here. Just ignore it. I don't really care. I'm going to write int if you hover over it. That's okay. No one's going to care because it's going to be treated the same way in the debugger. So that's what we'll do. And then apart from that, this here, unsigned long. So these are types. So basically, if I don't have a range and I don't have any way of figuring out, I'm going to have to just hard code it. That's what this means. So what is an unsigned long, right? So I guess what we're going to have to say is if no range is specified, then it means it's the default integer type, just like how int is here, right? If nothing is specified, it's whatever an int should be. I think that should be fine. Let me see, long unsigned. Actually, okay, no, that one's of type. Yeah, no, it doesn't make sense what I'm saying. Because if long unsigned int, oh, okay, wait, sorry. I just realized the reason why these are not defined is because they are already defined above. That's cool, okay. So that's just an alias for int. This is an alias, unsigned long, for unsigned long int. So if you type this in a debugger, then it just means the same thing as that type. Long unsigned int is the same thing as T8 here, which is long unsigned int, so we're good there. Okay, all right. Okay, this is starting to clarify a lot more. Okay, good. Okay, so let's start writing some code for this. So let's handle the case where we have no range. I think that's what we'll do. If, how do we do this again? If match else sim match of 4. Oh, there was a reason why I had spaces here. It's because these here are a subgroup of this one. Okay, so if I have a subrange, so let's say this, const bool has range. I suppose I should also immediately look at, okay, no, we'll start with that. Through what? I was looking to see if on a match there is a like operator bool or something. Okay, so we got size, we have empty. Is there an implicit bool cast? It looked like they had one. Well, I guess we'll call it empty. So, okay. Is it an alias for an existing type? Or if it's an alias for an existing type, just skip it. We will always display the first type, not the alias names. I'll put here an example. Example like signed is an alias for int. I just want to give one more. For unsigned long int. Okay, so I need to start storing these types. I have here type ID to type, yes. So there we go. I'm already adding them to a map, right? Yes, indeed. All right, cool. So if type def ID dot find of type def ID. I actually think I have a contains helper. Anyway, if type ID is equal to end, what do we do? Return? This is why it's getting way too long. I need functions for these things. I guess I could return. Ridiculous. Yep. All right. Okay, so otherwise, if it has no range, hey, why didn't it like this? Has no member empty. I guess I could do that. That should work. Okay. So if it has a range, I suppose what I'll do here is I'll go like this. Const auto range equals to that. Oh no, it's okay, because I actually don't care about the value of the range. I just want to know if it has one, because then I'll take the parts of the range after that. Okay, so if it's an alias. If it's not an alias, then we need to kind of deduce the type ourselves. That's what it means. So I guess what it means is it's an integer type. And I think the only types I see, if we ignore aliases, that don't have that don't have anything, so assigned as an alias, there's int and then there's void. That's the only ones I can really see here. Oh yeah, bool is somewhat special here because this is not actually a range. I don't think I'm matching this one actually, now that I look at it. Huh. Oh yeah, the equals E. Wait, is bool... So this means that the compiler is doing this. I think the compiler is saying bool is this kind of internal enumerator with E false and E true, and with the false and true values. I think that's what this is meaning, because I don't have, whoops, I don't have bool defined in my code. Yeah, I definitely don't. Oh, that's interesting. Handle bool, which is an enum type. Handle enum types, basically. Okay. Since no range is given, we need to just know the type. We must are expected to just know the type. So, for example, we'll say if type name is int, let's make a little helper local function here. I'm going to want to give it the type name. I'm going to want to say whether it's signed or not, and the byte size. I think that's all I need to do. Yeah. Looking down here. I need to add this to the type ID to type, so I'll need a type def ID as well. Okay. Now, signed will be true, and then here the byte size. Now, here's the thing. I don't know what the byte size is. It can be 1 or it can be 2. So there is something I need to do depending on what was passed to the compiler. Byte size is 1 or 2. Depending on if -m int 8 was passed or not. Need to figure that out, or have the user tell us. Like, it can be a configuration thing, you know? You could configure the debugger to say, I'm using 8-bit ints, or 16-bit ints. For now, I know I'm using just the 1, so I'll just do that, the 1 byte. But yeah, that's something we have to take care of. All right, so if we did that, okay, else if type name is equal to void. Now, void is not really a type. I think it's only there for void pointers. So yeah, it's kind of special. It's not really signed. Not really sure what to put here for the type size. I'm going to put 0. It has no size. Maybe that'll help me later on if I need to know if I'm dealing with a void type. I really shouldn't be able to display a void type anyway. Match on the types we've seen so far in RST files or in stabs that don't specify a range. Okay. Well, I guess I don't really need a return here. I can do else. So now range types. So what do we do for range? We have the type definition number that this is a range of, which I was looking at before again, and was that we had that weird thing with the float, right? Yeah, there's also that thing of how to format these that I'm not really taking care of right now. Yeah, that's true. I think basically what I have to deal with here for these types is that when I think about the classes of ways to format the values, there is integral types, which are signed or unsigned, and those I can figure out how to format. So integral. There's char, which, you know, it is an integral type, but typically people want to see the character value for it, maybe, right? Or both like the value and the, let's say, ASCII character that it goes with. And then there's floating point types. So I sort of need to know those things for doing the formatting. Okay. I'm going to start with this and see how far I get with this. I think I wonder if I can deduce it for the most part. We call this type name because I find it confusing otherwise. So, okay, if the type name is float double, or if it contains float or double, I should say. I think I need to go get my string utils to help me out here. Do I have no. Thought I had something to help me with this kind of crap. Where is it? I had something for seeing if a container, oh yeah, here we go. I have contains. It's not exactly what I'm looking for, but that's useful for my like maps and stuff like that. Actually, yeah, no, this would work, wouldn't it? So let's go like Actually, I think in either case, I just use %f and it'll just do the right thing. Okay, good. Else, if contains something like char, although there is wchar_t, which I probably don't want to display that way, right? I guess I kind of do, I don't know. Okay, I know what I'll do. I'll say if it contains that and the byte size is equal to 1, and do I care if it's signed? I'll do that, %c. Else, we're going to say it's an integral type. And we'll use, now this I do need to say, let me go take a look again. I always forget. Right, so it's D or I for signed decimal. So I do want to look at that. And then this unsigned decimal. Yeah, this idea of using a format string might not be good enough. We may need an alternate for hexadecimal. Like, this is going to be much more complex, I think, than just doing it this way. I might actually have to do this kind of formatting, not here, but maybe what I should be storing instead is not actually store a format string, but store, it's like what I was saying, is it a floating point type, is it an integral type, or is it a character type? And then if I do that as an enumerator, then I can do this kind of formatting, instead of like doing it here and sticking to this kind of printf thing, we can do something later. And then if it's hexadecimal, I can make those decisions. Yeah, I think I like that better. So let's do that. So if we get rid of this, I don't know what to call it exactly, but a primitive type class, floating point, integral, character, or maybe I just say like float int char. Or maybe I can call it primitive display type. I don't know. What are these called? These groupings. Generally, we say floats, integrals. These are formats, I guess. I am using the word format, so I suppose it is formats. It is a format specifier. So maybe what we'll do is we'll go like this. We'll put it back in here. We'll say format. Yeah, int char float. let's keep going. So now we've got the ones there. Let's start working on range types for whatever it's worth. I think then, you know, in that case, I think I'm just going to ignore the type it refers to. Because it's not actually helpful. For example, float is apparently a range of type int. Let's just use it to determine the byte size. Byte size and signedness. Signedness? I don't know. Signed? I don't know. Sign. There you go. So we go lower bound and upper bound. That's what we need. So it's 6 and 7. And in fact, they're always numbers, so let's immediately convert them to numbers. So it's stood S to I. If lower bound is less than upper bound, if, all right, okay, so we know we have a proper range here. So what do we need to do here for our type? We're gonna add a type by looking at the size, the number of values, and what? Basically what, the log, base 2 of it, to get the byte size. So 255, it's probably a smarter way to do this. Because I could count in hex the number of bits. Or I can like just do a simple mask to no. Or maybe I will do the log. Might have to add 1. Is there like a yeah, because if I do this, if I get a range, then what's the smartest way? I guess I could just shift bits, figure out how many bits I need. Oh, you know what? I'll be right back. Hold on a second. Sorry about that. Okay, so I think what I'm going to do is I'll just do a log base 2. That'll actually give me the number of bits in binary, and then just divide that by 8 to get into bytes. Should be good because my ranges should be, yeah, that should be good here. Just looking at all the ranges. They usually are just powers of 2 anyway. So, okay, so let's do that. So if lower bound is less than upper bound, then what we want is we want to do, is there like a log 2f? Yeah, log 2 of upper bound minus lower bound plus 1 divided by 8. That would be our byte size. And I think that's enough for us to already add our data type. So let's do add type def ID, type name, which we already have. Now for signedness, we'll just look at if the lower bound is less than 0. That should make sense. If it is, it's a signed type. And then finally the byte size. Actually, it's not, I think I missed one, right? The first argument was, no, that's right. And then the size. All right, let's do that. Now, if the lower bound is not less than the upper bound, I guess I should say less than or equal to. All right, this is a special case. Special case where lower bound specifies the number of, was it bytes, bits, bits, I forget. Let's see, 4, yeah. Bytes. And as for signedness, I don't know. I guess we have to say true for those types, because there's no such thing really as an unsigned float or anything like that. These are signed types, but we don't really give a crap about whether they are or not when it comes to formatting. So it really only matters for integral types. Okay, so that actually should get us most types. We're going to miss bool when we're done. We're still going to be missing this one because it has a different format. So I think when we get to this line, this is not going to be matching our regular expression because we're looking for equals R for range, not equals E for enum. We're not going to match the pointer types yet, so that's all right. So this one here and this one here will not be, but all the other ones should be matched if I did this correctly. So let's see if this builds, and let's see what we've got. Oh, I think my contains is not going to work. That's too bad. So let's see here. Let's see why. Is signed is an unreferenced formal parameter. Is that true? It is indeed. Thank you, compiler. Conversion from double to size t, possible loss of data. Right. That's okay. Oh, that's gross. Sometimes the formatting can be so bad. Does this help? Not much. There we go. Say number of bits. I think a lot of this will be reformatted better once, because it's too deeply nested. Once I start refactoring this into functions, it's going to come back out here, and it's going to look much better. All right, next thing is see context. All right, so what is it doesn't like here? We're calling begin on a string and end on a string and looking for a value. I suppose that's because we should be looking for a character in a string. Yeah, that's not going to work. Did I not have something to look for something inside a string? I have split, join, trim, to lower, remove, replace. I suppose I should just add a contains in here. Yeah, this one should be pretty easy because we just want to do find this and return that it's not equal to there we go. I mean, I could do the same thing, I suppose, without using this utility. Yeah, let me just do that. Am I still calling this somewhere? Oh, Yeah. Okay, it looks like it's compiling now. All right. Let's see. Actually, before I attach, I want to just set some breakpoints here just to see like if it's doing what we expect. Just put one in here. I guess I should remove this code. And what was the other thing I wanted to do? Yeah, I want to put a breakpoint at the bottom. On our way out, we should take a look at our debug info and see all the types that we've added. In fact, I don't really need to launch. Let me see. So I think if I just hit F5, we should be able to get to that point. Yeah. Okay, so the first one is because we're parsing that first source file that does not have any symbols. Hit F5. Okay, so here we are. What does our current line look like that we are parsing? Here it is. So we're parsing complex long double. So let's see how we fare with this one. Yeah, I can see here lsim string is complex long double. I'm going to actually pull out lsim match here. So there's the split. 5 and 6 or 3 and 8. Oh, is it 5 and 6? Oh yeah, no, that's fine. Yeah, okay, cool. So let's see how this goes. So is it a type? It is. It's a T. So we grab the type name, the type def ID. So type name is complex long double. Type def ID is 3. The has range is going to be true. Great. So we come in here, we grab the 2 bounds. Lower bound is not showing up in the debugger, and neither is upper bound, which sucks. But I saw that it's 8 and 0, so we're going to fall into the special case here, where we add a type where the size is going to... why am I not getting anything here? But anyway, I could actually just immediately take a look at my debug symbols. Really? Okay, so we've got a type in my debug symbols here. I just want to go see that it says that it's 8. So there's complex long double. It's of type float, which makes sense. And byte size is 1. Was it supposed to be 1? Should have been 8, right? Okay, well the next one will be very similar, so let's see if we can drill down into what's happening here. We've got a complex long double here. Why can't I see these values? 6 and 7. So 6 is 8, 7 is 0. So are we not just passing the lower bound in here? Is my S to I not doing the right thing? Here, let's look in the disassembly here. Yeah, so it ended up in a register. So there's 8 and there's 0. So jump greater. Okay, so it inlined the body of that function. Or did it? I see, no, it's okay, no, it's going to do a call here. Ah. Yeah. There's the problem. I need to set the byte size in the actual thing here. That might help. So part of me just feels like seeing what happens if I just go. All right, we get a crash, out of range. What's going on here? Oh, do I need to do S to L? Oh, I might. Huh, that's true. Can't store this value. I don't need to store it, actually, for the upper bound. Okay. Actually, I don't even need to cast it, do I? Yeah, I think I just need to change it to S to L. I gotta support long values. Let's try that again. Still getting an out of range. S to L. String to unsigned long. Oh, I see. Oh, that sucks. Maybe I should just take like the largest one of all. Like string to long long. It's kind of ridiculous, but I suppose that would do. that case, I will cast this just for compilers where size t might not be the same type as same size as long long. Okay, did not crash this time. So let's see what our debug symbols look like. I'll pull it up in the quick watch here. So by now we've added a bunch of stuff to this, and we have 12 types. So 12 types that should correspond to 12 types in here. Let me just take a quick look at these, see if anything looks wrong. Maybe I can copy these because it's kind of hard to read for you guys. Unfortunately, it doesn't display everything in there. So let me try that again. Yeah, because the part that's not showing up is whether or not it's signed. It's kind of annoying. Okay, so we've got these types that I'm not going to really use, but there they are with their byte size of 8, which is what they were reporting. Okay, same thing here, complex float, byte size of 8, sure. Number 3, that's our long unsigned int. It's 4 bytes, apparently. Yep. It's not signed, which makes sense. Or does, yeah, unsigned int, indeed. Got long unsigned int, that's a 2 byte. That is not signed. Our unsigned int is a 1 byte integer. Looking good. Is it signed? No. Good. And next one, char, 1 byte. So char is not considered signed because it, oh yeah, that's right, because the range was 0 to 255. So there you have it. It is what it is. Because you can specify whether chars are signed or unsigned to the compiler. So I guess in this case, it is unsigned by default. Doesn't really matter. Short unsigned int. This guy is an int, 1 byte. It is unsigned, correct. What are my signed integers? Looks like I haven't gotten one yet. These are all unsigned. There's another unsigned char. So that's weird, right? Unsigned char is unsigned, but the regular char is also unsigned because of the range. Yeah. That might be a bit strange. Probably we're going to have to override that. Or maybe it's something we could pass to the compiler. Let me see. Because if I can pass it to the compiler, I won't bother with it. GCC char signed or unsigned. In the book Complete Reference of C, it is mentioned that char is by default unsigned. The book is wrong. The standard does not specify if plain char is signed or unsigned. Right. In fact, the standard defines 3 distinct types: char, signed char, and unsigned char. If you include limits and then look at char min, you can find out if plain char is signed or unsigned. If char min is less than 0 or equal to 0, but even then the 3 types are distinct as far as the standard is concerned. Sure. For GCC, the default is signed, but you can modify that with -f unsigned char. You can also explicitly ask for it to be signed. Huh, so you know what? That would be interesting to see. I'm curious. I have my make file here. We don't specify, right? F sign dash F sign char. So that's the int 8 over here I was talking about. So like if I did C flags plus equals to dash F signed char, would that change anything? I think I need to. Okay, I'll do that right after I debug this. Just finish looking at this. We got float. One thing I don't think I saw was just plain int. We got float. We got double. Okay. We got long double. Okay, that's cool, but yeah, I think we're missing types here. So complex long, complex. So complex int did not get parsed out. Looks like anything with int didn't get parsed. We got long, unsigned, and unsigned. Oh, unsigned int got parsed, it's true. For some reason complex int didn't. Oh, it's probably because of this equals to s thing here. Yeah, that's true. Yeah, I don't care too much about it, but we should probably handle that or figure out what the hell that means. All right, but then if we just keep going, we've got unsigned int, we've got long int. Why didn't this one get picked up? In fact, whoops. In fact, what happened was that from here all the way down to unsigned int, yeah, these 3 lines got skipped. So these 3 lines got skipped for some reason. I'm trying to look at the data. Oh, okay. You know what? It's the negative, isn't it? Well, at least for these 2. I'm guessing that my matcher isn't matching, isn't expecting perhaps a sign to be present. So that's why I don't have short int either. So anything that's signed is not showing up because of that. But what doesn't make sense so much is this one here. Should have matched this one because I have a if there is no range, right? So maybe I didn't write that correctly. I guess we'll take a look. Or maybe it's not my matcher, but it's my code that looks for if it was found. Okay, so we're almost there. So yeah, let me just compile this program here now that I've modified the make file to say that chars are signed, just to see if this has any bearing on the generated RST file. Where is it? Doesn't look like it. And if I remove the mint 8, let's just see what that does. Oh, you know what? I know what's happening because it's having no effect, and that's because makefile changes don't. I haven't like correctly made the makefile rebuild or detect that the makefile change should cause a recompile of everything. I'm not super used to make files, so I typically spend too much time trying to figure out how to do this properly. So what I do usually in this case is I clean and then I build again. Effectively, I do a rebuild. Not the smartest thing. I really need to figure out how to detect makefile changes and have it do the right thing. Okay, so this got rebuilt. I know because we're now at the top here. Oh, and now, wow, that's weird. So char now is saying it's 0 to 127. 0. Wow, that's weird. Why isn't it minus 128? It's terrible. And I think now that what's going to happen if I do this is it's going to say that the number of bits is 0 for this type, right? Because it's not even, you know, the log 2 of this is going to give me 7 bits, which I divide by 8. Is that true? Yeah, it is true, right? Well, I think so. Let me see. Really, this stabs format, it's not great. I'm sure like every stabs parser out there is full of hacks to work around all this weirdness. Yeah, so there you go. Byte size is 0. Oh yeah, that's just awesome. So I guess what I'll do for that, what will I do for that? It's just weird. You know, you've got types like complex int over here that gives a proper range. These signed ranges are all over the place. Short int, and then good old char giving us a 0 to 127. This means I have to hack it. This is one way one way to hack it. I mean, I don't know if I should do it at this level or if I should do it where we look at the range. Not sure. Okay, I have another idea for this. If numbits modulo 8 is not equal to 0, or maybe I'll do like this, while numbits modulo 8. I kind of need to know though if this happens. Hack. Sometimes the range will be something like 0 to 127 instead of minus 128 to 127. For these cases, let's assume it's signed and increase number of bits until it's a power, or until it's a valid byte multiple or 8-bit multiple. Hopefully this kind of thing will catch. Like if there was, what I want to take care of here is what if we get not just 0 to 127, but like, you know, 0 to sorry, got distracted there. So like, let's say we get like 0 to 32,767. That's another case, right? And in that case, we want four bytes, and we would get 3. So what we would do there is we're going to get 31 bits, and we'll increment it to 32, and we should be okay. I mean, sorry, we'll get 15 bits, and then it'll go to 16 bits, and then we'll consider it a signed type. So if I look now with this weird version that has a 0 to 127, our char should at least look correct. Yeah, there it is. Char, and it is considered a signed type with a byte size of 1. Okay, cool. So at least we have a way with, I mean, I don't know if the compiler does the right thing there. Like if you know, the fact that it's reporting 0 to 128, I'm hoping is, or 0 to 127, I'm hoping this is just like a weirdness of the stabs format, but that the compiler correctly allows you to store negative values in there. You know, it's weird, right? Obviously it's not going to be a 7-bit type, right? I hope. So I'm just going to take this as an oddity of the stabs format being output here. Okay, so let's handle the negative values to get the rest of our types. We're really close. I can't wait to start seeing different data types. So where is it again? So I guess that is going to be in our regex. It's right here. So everywhere we have a digit, I'm going to have to add a negative, an optional negative, I suppose. Yeah. Well, not here, but in my range. So there, whoops, that's not what I meant to do. Control V and Control V. Okay. Let's see if we got more types in. We got 0 types. So that was wrong. Let me go take a look. Oh, right. I have to say this is 0 or more, or I guess it's this or nothing, right? That's how I have to say, like that. Still no good. Let me use this trusty matcher here. So first it should be able to match this guy. I don't even remember how far did I... Why isn't this working? Oh, wait. Oh, here. Hey, thanks for the follow. Was it Caltinril? Or was that a subscribe? Sorry, I couldn't see that. It went a little bit too fast, but thank you very much anyway. Appreciate it. Oh, it's subscribed. All right, thanks, man. I see that. Very nice. Still working on the debugger for Vectrex. Yeah, man, how's it going? Yeah, totally. I mean, I think I'm going to be working on this for a long time, to be honest with you. But you know what? It's super interesting. I'm really enjoying this. Okay, so I'm not sure what's going on here, but okay, so it's not that the Vectrex requires a complicated debugger. I wrote a debugger, like a command line sort of GDB style debugger before, and I have that and it works, and it's not nearly as complicated. It's got some complexity to it, but nothing like this. What I'm doing though is not quite that, right? I'm trying to write a debugger for C and C++, right? So yeah, so that's what is complicated. You know what I mean? Making a source level debugger on top of this emulator is more complex for sure. And then for that I got to be able to like parse out this crazy debug info, which has a really weird format, and for which some reason I can't seem to use. Oh wait, no, sorry. Yeah, there we go. Hey, that's good. I think I was just taking too much. Yeah, that's right. Okay, I only care about what's inside the quotes here. But yeah, that's why it's complicated. It's otherwise it's not so bad. So now this works for that, but I'm trying to make it match with negative values in the regular expression. So yeah, so here we can see that it breaks down. If I just add a negative in here, then it matches that. But if I put that in, okay, so there it worked. Oh no, it didn't work for the other case. Now with a star it works, so I could do that. But really what I want to do is this or nothing. But why doesn't that work? I stopped using rack because of the negative connotations. Been using Caltinril. Am I saying that right? Caltinril? Caltinril. Caltinril. I don't know. I don't know how to say it since EverQuest days. Yeah, no, I remember. We spoke a few weeks ago or something, right? I mean, we've known each other for a while, like from the old days. Was it 2 months back? Wow, okay. So I guess it was before the event. Okay, I think I know what it is. I would have to like do a capture for it to do the not symbol. Yeah, pre-apocalyptic, exactly. Like if I want to be able to do this or nothing, I think I have to do like this, like that, in a capture. But then if I do that, it adds another capture, which messes up my indices, which sucks. I don't really want to capture it. But I think that's like the only way I know of in regex to say I want something or nothing. It seems to be in a capture. Is that something or nothing? Oh wait, is there a difference with question mark colon? You could, but then the matic would be held in a capturing group. Ah, look at that. Well, there you go. See? Learning things every day. You try to avoid regex when you can. Yeah, that's a healthy choice right there. You know, stay away from fatty foods and regex, right? Whoops. Yeah, I don't even have to open that XKCD to know what it is. You have a problem, you use regex, now you've got two problems. The classic. Okay, so if I do this, the capture group does disappear. Oh, that's cool. That technically means that I could get rid of this outer capture group, I suppose. Yeah, it does work. See, right now I have this group 4 that corresponds to this whole thing, and then I break it down. But if I put this question mark colon, that group 4 disappears. But I am using it right now to know whether or not I have a range. So I think I'm going to hold on to that one. But for this one, this could be useful for the negative. I like that. It's either a negative or nothing. Now, honestly, like there are ways to write regex more cleanly. You can put like labels and stuff, and you can also break it down and like you can sort of create substrings and then build up your regex from subparts to match. Like for example, I could call this matching a number, right, a digit, rather than write it out like I do. I could write this whole thing actually should just be a digit matcher. And then it's a lot more easy to read. And you can give names to groups, and then you can look for things by name rather than by index. There are ways to make regex more readable. There's even ways to format regex, to make it more readable. But yeah, I'm a bit lazy. Yeah. Okay, so technically I should add it here, even though, yeah. Okay, so that looks like that would work. Let's bring that in. So what you been up to? Have you been working from home? I think I don't know, I've spoken about this to so many people, I don't remember. We made a compiler for a fake language in college, but we used Lua and we had 3 parts, Lexer, interpreter, compiler, and then we made a REPL program to use them. Yeah, always loved doing that kind of thing. Right. Okay, so look at that. We captured 17 types, and I can see we've got our char in there. We've got our short int. So now we've got our integer type somewhere, right? Okay, well, we got more types, but I don't see int. So we're still not getting int. Oh yes, that was the other problem. There were 2 different problems. There was the assignedness problem with the negative, and there was a problem, I think, with this is type. No, sorry, with this is range. Where did I put that? Has range. I think I'm not getting the... I think I'm not getting inside here. Apex Legends? I suppose I should know what that is, right? I don't know, I am in here. I do get in here, I should say. Okay, so there's int. So what's the deal? We've got this, int colon t7. Ah, it already found type 7. First person shooter, battle royale, kind of like Fortnite or PUBG. Oh, okay. Is it like, because I know Fortnite and PUBG is, so is this like the newer thing that people are playing now? That's... Or does it predate those? Yeah, it's newer. Right. Okay. Yeah, I guess I totally missed it. It came out a year ago. Yeah, that sort of coincides with about the time I left video games. It's surely if I had still been in video games, I would know this by now. I mean, I would have known about that. But I'm no longer in video games, and so I don't keep up to date with what's coming out. Okay, so what's happening here is that type 7 was seemingly defined already. How's that possible? Since int defines t7 first. Did you say you should give up gaming? Why would you give up gaming? Okay, so it's not in here. 7's not in here. So what? Oh, wait a minute. Wait. No, yes. No, okay, this should be not equals to. It showed int and signed in your find. Did it? Basically, in the list, I did not have just type int alone. And now I can see why. There we go. So now I have an int, so I add it. The next time I come in here, it's for signed. This guy should not do anything because it's an alias. Here we have unsigned long. That's also an alias, so we skip that. Another alias. Basically, when I say alias there, it's what I mean is like signed here is just has the same meaning as signed in. That's why it has the same type. So I don't really care. I could have like alternate names type of thing if I want, but for debugging purposes, I wouldn't be able to really display it. However, it is possible that I might have to store these alternate names for being able to type expressions in a watch window. If somebody wants to do like a cast expression and I want to support that, they might type signed and I'll have to say, oh, what is that? Oh, that's an int, you know? So, but for now, I'm not really supporting like, you know, crazy expressions or anything. So I won't bother with storing aliases. Okay, so now I've got 19 types parsed out. So that sounds promising. I should count how many I expect to be parsed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, actually, I should skip aliases, right? So, okay, let's do this. Let's grab this list. I'll grab the whole thing. All right, so we don't expect that one. We should get these. T10, 11, 12, 7, 13. So not this one. So I'll move that down, I guess. T9, I think, yeah, that's another alias. So is T8. So these two down here. 14, 15. This is an alias, 15. 16, 17, 18, 19, 20. Void is type 2. 21, 22, and then this one here. And then this one I won't parse yet because it's a pointer. And bool I won't parse because it's an enumerator. So, I mean, I don't really have a place to put my aliases. Ultimately, it's not going to matter. The fact that they have the same type number means that in the rest of the debug info, whenever there's a type declared, it's just going to say, like, here's a variable of type 7. So type 7, it could mean any of those types. So it doesn't really matter. Like I said, it will only ever matter if, you know, I enable complex expressions in the watch window, like for casts. So somebody might type, you know, signed or unsigned long. And in those instances, I would need to match this type with my list of types. So right now, if someone were to do that, to write unsigned long, and I don't store this anywhere, I'll say, I don't know what this type means, right? But what I need to do is I will need to have lists of alternate names for types. And then when you look it up, it'll say, you know, maybe I'll just store it in my debug info, like, you know, look up type by name, and then I'll have like a map of type names to the type. and then all these alternates will point to the same type, and then that'll do the trick. That's most likely what I'll do, but I'll do it when I need to do it. Since I'm not even supporting these kinds of things yet, I'm not quite there. I won't bother with that. But you know what? I will make a note in my to-do list. I'll put it as part of my watch notes here. Right now, the RST parsing, or I should say the stabs parsing, skips alias types. For int, for if we to support like support casting or support like complex cast expressions in watch, we'll need to store these alternate alias types. Keep a map of type name to type in the debug info. This way we can look them up and know how to interpret type. So yeah, so you're suggesting I use like GitHub's tracking ticket stuff. That's true, but you know what? It's me alone working on this. This is way faster for me to just like, you know, use a text document and type it in. I agree though, like if I was collaborating with people, I would totally do it, right? And definitely if people have problems, they can go and log tickets there, and I would, you know, work on them that way and close them. But honestly, in all the years I've been working, I've never found anything really better than just a plain old text file with a bunch of notes in it. Oh yeah, it's true, right? Is my keyboard camera not working? You're so right. Let's see if I... Oh, that's a shame. Wonder how long that's been. Let me try... Here, you'll see me twice. Try and reinitialize it. Oh, there we go. Hey, thanks for pointing that out. It's a whole stream of me pretending to type. That's what it'll look like. Oh yeah, my face is frozen. What? 1 second. Oh jeez. Okay, I think everything's working now. I probably messed it up because I tried to switch the keyboard camera to my face camera, and that probably messed it up. Now I just tried deactivate, activate, and it seems to have done the trick. Everything look okay now? Yeah, COVID-19, the whole thing. Pain in the ass. All right. Okay, good. So, what was I doing? Oh yeah, I was working on my list and trying to count how many types I have. So let's see. I guess I should have, according to this, I should have 20 types, but I think I have 19, unless I like missed one. Let me see. Oh yeah, this guy is not parsed correctly. This is a what? I don't understand this type at all. It's an S2 real 7 range, and then it's got more crap after it. 08 image 788. I don't know. I haven't seen anything that explains this weird looking type. But the good news is I don't care. I don't think I'm gonna type complex int anywhere, and if anybody ever writes to me and says, hey, I tried to use complex int and it's not displaying correctly in your debugger, I will then take a look at this. But I really don't care, because I don't think anyone uses those. Those are extension types, right? There you go. Send me a PR with the fix. Exactly. So these are my aliases over here. And then these are pointers. So that's, I'm going to have to do the pointers later. All right, so next, this is great. What we need to do now that this is all done, is we go and unhack and properly do some formatting in the DAP debugger. All right, so here I say hack assume int sign char really. Okay, so we've got our var, we've got our address. Now, if it's more than 1 byte, I suppose I have to read in sequence. I think that's correct. Let me think for a second. Got a stack pointer, and I've got offsets in the positive direction. Yeah, I'm not sure yet for multi-byte, so we're going to take a look. Obviously, it's one way or the other. And I'm going to have to combine those. It doesn't really work that way. I mean, no, it does. I guess I don't know, to be honest. I have to take a look. That's sort of the question here. Is it big endian or little endian? Yeah. The compiler basically will decide how to lay those out on the stack. It's because the thing is, there isn't really an integer data type here, you know? The Vectrex is a 16-bit bus with a 8-bit value at each address. You know what I mean? So, yeah, I mean, it's just, I guess it is endianness in terms of like how it's laid out. So we'll find out. Why it doesn't like this? Oh, it's an error. Okay. I can't rely on my. Ah, yes, this problem. Okay, so for now, I'm gonna just extract the. I forget if this is how you do it. Yeah, thought that's how it's done. Oh, okay, it's because I need to dereference this guy. There was a version, it was not get, it was get if, I think. Yeah, sorry if it's not clear. I'm get if, that's the one I want to use. That's right. So basically, I'm using a variant. I'm probably going to change this. I don't know. We'll see. It's either this or inheritance. And for now, I'm trying this, and we'll see how it goes. And eventually, I might change it to inheritance and whatever. If I do that, then I'll probably have to push the formatting into the types. But right now, by using this, I can do some kind of like dynamic cast, if you will, by checking the type. Yeah. Okay, and I think I need to make this a pointer here. This is kind of gross. What is this I want to do here? I guess I want to dereference this type and get its address. Ah, so gross. What do I want to do? I want to use the address of my variant, but type is a pointer to the type, so I have to do something gross like that. There we go. That looks less gross, and we can constify it and constify it here because I'm not going to modify it. C++, complicated. All right, so we got a primitive type finally. Yeah, this is the part about C++ that trips up most people, and I'm, myself included. If I do this, this will actually be happier. Let's just see. Because see, autocomplete doesn't work unless I write this. What? that what it's complaining about? This is why people use auto. So you don't have to figure it out. All right, so let's say I've got a primitive type. I'm going to need to look at the format, if it's an int, a char, or a float, and then the byte size. Okay, so first I guess we'll grab out the byte size. Yeah, this is not going to be super fun, but this is the point, right? Like this is like where we take the type and we figure out how to format it. So this will likely end up in a function somewhere, or like I said, maybe it'll go into a class hierarchy. We'll see. So I guess first what we want to do is we're going to want to loop. Is that what I called it? Byte size. I don't like when this happens. Why does it say this? It is a pointer to class type. Oh, do I have like a pointer to pointer? Is that why? Ah, right. Okay, that's right. So getIf is kind of funny, because getIf basically returns a pointer to this type or null. So you're not supposed to write the pointer. So it was returning a pointer to pointer. That's where all this weirdness was coming from. So it's my bad. All right, that makes a lot more sense. There we go, const primitive type stars. Forget these things. So one thing is I'm going to need to like store this type in some kind of maximally sized buffer that I can use, that I can alias. So I'll say like, call it value. I want to add an assert that my byte size is no longer larger than this. So I'll do that here, I suppose. Assert that primitive type byte size is less than or equal to std size of value. Okay. Oh, I lost my... Yeah, I did. You caught that? Oh, there it is. So that makes sure it's going to be able to fit inside there. I don't like having to, no, that's okay, that's okay. And then what we'll do now is, yeah, you saw what I did. I basically did undo until I saw it. I copied it into my clipboard, then I redid until I was back to where I was, and then I was able to paste it. Oh yeah, that's Spidey sense. I know what you mean, man. You know, there's these extensions, like these plugins you can install, like in Windows or even in your editor for like a clipboard, like a multi-clipboard, sort of like a circular queue of clipboard stuff. Yeah. Those are useful from time to time. Yeah. There's been a few occasions where I found them to be useful. So here I'm going to start reading from var address. Now it's either plus plus or minus minus. Like basically I know the offsets are positive, so I'm pretty sure it's plus plus. But I don't know if, I mean it is plus plus, but I don't know if I have to read them in reverse or not. So we'll see. I'll do tests with multi-bytes and we'll see multi-byte values and we'll see what we get. All right, so let's say I've read now my value into this value array. The next thing to do is to do the formatting. So we go switch prim type. Oh, I gotta do inside here. Switch prim type of format. So now I gotta do all three cases. Can it autocomplete for me? Visual Studio, man. Should be better than that. I want int, char, and float. All right, so for integers, once again, we're going to have to look at the size to figure out how to format this thing. Actually, do I? I don't think I need to. Oh, yeah. All right. I do need to. Maybe I could just copy into the largest type that I can print and just print that. Oh no, but then I gotta take care of wraparound and all that stuff for like signed values. Unsigned is easy, but signed values is more of a pain. So I was just thinking to myself how much I wish I could use std format for this. Std fmt is this library that's coming in C++ 20. Or no, sorry, std format like this. They renamed it for the standard. And it's like, it's basically what printf should be. Or I guess it's what cout should be. It's like printf, but type safe and really, really powerful. A bit like Python, and I think this would help me a lot in this case. But I don't have that, and so I'm going to have to do this myself. All right, so let's do this. Let's go switch. In fact, I should do a mem copy. In fact, I need to know whether it's signed or unsigned. Well, I guess I don't need to know it here. I could just make the decision based right here on what's the format string I want to use. Yeah, it's bytes, right? So it's basically the byte size. So if the byte size is 1, that's 8 bits. So it's a uint 8t. So normally if it was this, let's say I forget signedness for now, it would be just if it was signed, I would want to use, what would I use? That's why I hate printf. Love-hate relationship with printf. I guess it's just %d for signed or %u for unsigned. I think that's going to be the case for all of these. It's just about the value I pass in. Is that true? What if I could use toString? Would be nice if I could. Maybe I could. If it's signed, we static cast to int8t rv, otherwise we just pass v. I think that should do it for that case. I actually don't think we can support 8, to be honest, but it's not much more code for me, so. Oh, sorry, it's supposed to be int, and then int64t here. So these are to do. I'm just going to leave those blank for now. Okay. So here we set the name, the value, the type. So yeah, let's get that from the var type like we said here. Actually, yeah, all right. Okay, so I think if I did this right, the different integer types should be working. So let's just see if this builds. It does not. Tell you one thing that nobody misses when they stop doing C++ is template errors. I don't understand why sometimes it can't give me the actual source code location where this is happening from. Oh, one lone coder. I haven't heard that name in a while, but I think I remember what you're talking about. I just want to ascertain that it is this get if. I'm quite sure it is. Right. Thanks, man. One thing though is one thing I can say is C++20 is going to improve the template error story. They have concepts. Is it concepts? No, yeah, no, it is concepts. And with concepts, you can give a name to what a type is supposed to be, and that's going to help tremendously, because when something failed, it'll be able to give you a message like, you know, this type doesn't fit this concept, it's missing these things, rather than just a big spew of template errors from the, you know, the recursive instantiation of data types. Okay, so it is this. So what's wrong with my getIf here? I'll try by removing the const to begin with, just to see how that goes. This really should work. My type here is const type. Okay, that worked. I suppose it is already a constant, so I don't need to say constant there. Yeah, it deduces it from the fact that this is const. Okay, cool. So if this behaves properly, and you know what, I'll put a breakpoint in here just to see that it does. Let's finally test this. So now I haven't changed anything, so it should just basically do the int thing, but through the new code path. So here we are, hit F10, hit F10, boom, okay, we hit our breakpoint. Let's see what's happening here. So we've got a primitive type. Let's see if it's the right one. Int, that looks good. Byte size of 1, and it's considered signed. Cool. So what happens? So we go in there, we read once into our value at address 0. It's got a value of 0, which, yeah, that makes sense. Come in here, we do a mem copy into v. It's got the value 0, and we do toString it, doing the correct cast, and our display value says 0. So this looks good. So let's just see if it works without me doing any more checks there. Okay, so b is minus 53 because it hasn't read anything yet, but now it's got 126, 127, 128, minus 128. Yeah, it wrapped around, so that makes sense. Perfect. 1, 2, 3, that looks good. Come back on main here. So let's shift F11. So this looks like it's doing as it was doing before. Yeah, it should show 120. Did I miss something? $126, 127. At 128, they should become minus 120. Like the next value should become minus 128. See? And then I add one more, and it should become minus 127. So maybe I was just going too fast. No, it's signed. It's signed. Remember, I was saying like I had to change my make file to tell it to treat it like a signed, or maybe you missed that. Maybe you joined after. I don't know. But basically, I'm saying that chars are signed, which to me makes sense because, you know, but that's the way I think of chars. They should be signed by default. Okay, so this looks cool. Let's pretend this works because it looks like it does, and let's try types that are of different width. So let's try, I'd like to try a 16-bit value here. So I guess long int, or was there another one here? Unsigned long int? Here, long unsigned int. I could also use just unsigned long, I suppose. Okay, let's go here. I'm just going to remove all this because now that I don't need to test scopes. I just want to test values. Let's keep this simple. We know that int a equals to 127 plus a. B, let's go 65,535. All right, let's go nuts. Yeah, I'll try that. So the thing is that ints are 1 byte for the Vectrex, or at least the way that we've set up the compiler. That's how it's being treated. I'll do char after, but I just want to start with these basic types. Integer constant is too large for unsigned long type. Okay, let's just start with this. It's kind of funny that's giving me that error, seeing as the debug info told me that's the type that can hold that size. Okay, F5. Okay. Oh, cool. It actually displays it correctly. That's pretty awesome. And in this case, it's unsigned, so it wrapped around to 0. Let me try a signed version. I want to just remove the wait for debugger, so I keep having to attach. It's annoying when I don't actually want to attach. So F5 here. So where are we? What just happened? Hold on a sec. Try that again. That was very weird. Oh, that just crapped out on me. Strange. So maybe I spoke too soon about detaching, not attaching my debugger. I guess I do. I gotta attach my debugger to the debugger to debug the debuggers, debugging the debugging thing. All right, debugception, exactly. Vectrexy. Aha, assert. What am I asserting on? Wow, that is certainly not the right byte size. What did I get here? Okay, so I've got some bad byte size initialization for my long int. Good thing I added that assert. I thought I checked all this stuff. I have to stop soon. I'm actually going over my usual time, but I guess I'm having too much fun. Oh yeah. Oh, I also have, oh no, that's all right. 4, 4, 4, 1. Oh yeah, look at that garbage here. Okay, so I've got some garbage for my signed types. Well, not all of them anyway. Short int. Oh no, I'm not staying on your account. Although I do enjoy the company, for sure. But no, it's really because I'm actually really enjoying this. Like, I'm excited to see different data types being displayed correctly in the variables view, you know? Yeah, thanks. Okay, so let me see here. Right, it's early for you. So numbits at 32, that looks like we should be okay. 16, 8, 8 again. Let me just put a breakpoint right there instead. Let's go again. So the very first one is wrong, so let's just step in there and see what's going on. So this one here should be, why can't I step into this? Byte size 0. No, size C is fine. I hate when, okay, you know what? I know how to uninline. What happens is these lambdas get inline sometimes, and then it's like impossible to debug. If I just put some kind of dummy printf, that usually takes care of it. Hopefully. You're probably wondering why I don't debug a debug build of my emulator, because that would definitely work here. But the debug build is too slow. And I started actually profiling it and finding why it was too slow, and I was able to get somewhere with that. But I didn't finish doing that yet, so. Okay, that's fine. Why isn't it stepping in? It's driving me nuts. This doesn't look right. It's too optimized for me to figure this out. Okay, let me try debug. It's going to be slow, but it's okay because it's slow when you try to parse the entire thing, but since this is early on in the file, it might actually be okay. I really need to speed up this debug build. The thing is, it's not a large number, right? Basically, I have an unsigned long here, and then I subtract the upper bound minus the lower bound here. It is true though, maybe that, oh, maybe, you know what? Now that I'm thinking about it. Yeah, okay, I see. Problem would be for something like this. Oh, okay, for any unsigned type, if I add 1, yeah, that's not gonna work. Yeah, I was just thinking maybe what I can do instead is, just give me a sec. So here it seemed to be okay. So I've got my big upper bound. I did, so there it is, log 2, 32. Byte size is 4, so that's good. Am I doing something to it? Oh, okay, I said it's my first one, but this has nothing to do with first. Okay. Yeah, it has to do with this. This minus that plus 1. That's not going to work. Well, it could work actually. So what am I missing here? Okay, let me stop when it says long int to actually see what's happening. And long int has a range, so we should break in here at least, and it's got a lower bound less than the upper bound. Oh, wait a minute. I think I just saw it. If I'm casting to unsigned long, then I'm not going to get... Okay, I see what's happening. What's happening is I'm treating this as unsigned, and therefore I get the case where lower bound is greater than upper bound. So I treat that as a special case and treat that as number of bytes. Okay. Is there this? I need to keep it signed. Yeah. A little reasoning and then it all makes sense. So now we should be okay. Okay, now that looks better. All right, let me switch back to release because I really do find it much too slow. Do that. Oh yeah. Yeah, dealing with the carry bit and dealing with overflow, depending on whether you want to do signed or unsigned numbers. You do actually have to mess with that when you're implementing an emulator. You have to, because you have, like, when you emulate the CPU, you got to be able to set the flags registers for overflow and for carry when you do operations like when you implement addition, for example. So you got to take care of that kind of stuff. Subtract with carry, add with carry. Correctly setting all the states so that, the code that's been written in assembly is expecting that stuff to be correct. Yeah, when I started writing emulators, I had forgotten everything about my assembly language class, and so I had to relearn all that stuff again. And I remember when I wrote my NES emulator, dealing with those operations, those instructions, add with carry and subtract with carry. Yeah, getting the chills. I mean, it's not so bad. I find it something kind of nice about these old machines. Definitely a lot less instructions to worry about. And the instruction sets were there for for programmers to write in assembly, so They're actually nice to program in. So this looks right, this goes to 0, and now this here, that does not look right. So my long signed int did not get the type I expected. Wait, what is a long signed int? Huh. Well, look at that. I guess what's happening here is I wrote a data type that's not in my list. Because I just took long unsigned int and removed the... Wow. That's interesting. But it's a type that the compiler knows. But it did not spit out in the stabs file. How about that? So I guess if I don't know what it is, then what am I doing? I guess it's, or maybe it's treating long signed int as, what am I doing with that one? Really? Your teacher did that? Did your teacher actually work at, like, your teacher left to go work at NASA? Shit, that's cool, man. It's really cool. Oh, he came back. Still, smart teacher. Okay, so let me get a breakpoint. So I've got three variables here. So let me just take a look here. I've got int, long unsigned int, and long int. So it took this to mean long int, which I guess makes sense. The sign is effectively ignored. But what sucks is that according to stabs, long unsigned int, where is it? So yeah, according to the stabs here, a long unsigned int here is a 16-bit type, but a long int, oh, a long int should be as well. Okay, so I have a mistake, I guess. So let's see what's happening. Because in my variables here, long int, which is the third one, points to, oh yeah, it's correct, int with a byte size of 2. So why didn't this print correctly? Okay, so the first one, it's just once. We go through. Second one, we go twice, which makes sense. Long unsigned int. Third one, got 2. $34,291. Okay. I haven't stepped the value yet, but $65,407. 65. Oh, if it was unsigned, right? This doesn't make much sense. So ignore this value here. This is garbage. What I don't understand is the value I'm reading out of memory is incorrect. It's, at least its unsigned value is 65,407, which is not correct. I mean, signed or unsigned, it should be that value. Really, it'll only matter if you add 1 to it. Well, okay, I can't use short, but 16t. If I do int, wait. Okay, there we go. Interesting. Okay. Parens matter. So this looks weird. We're trying to write a value of 32,767 to the stack, and instead we're coming up with something entirely different, 65,407. So it's at stack offset 3, 0. So stack offset 0 is the first one, because it's all packed. Then at the second variable, we can look at here. So the first one is at offset 0, and then the second one is at offset 1, which makes sense. And then this one should be at 3, because 1 is 2 bytes. So we read the 2 bytes off of it, and we store that into value of 0 and value of 1. So we have a 127 and a -1 in there. So if we shift left this guy by 8 and OR it with value of 1, we get -1. And if we do the other way around, actually, I think that was right. Let's say we say that this is a short So if I do the math myself, where I cast the first byte, shift it left to 8, and then cast the second byte to unsigned short and OR them, I get what I expect, which is 65,535. Now, if it were signed, this result, actually, is that correct? No, that's not correct. No, that's not correct at all. What I'm wondering is the debugger doing something funky? Let's go see what the code looks like that got generated. I mean, not the debugger, sorry, the compiler. Is it doing something unexpected here? So if we look for C, so here's load X 32,767. So it loads that immediate value into there. And then it says store X at offset 3 from the stack. I mean, it doesn't get much more simple than that, does it? So those 2 bytes, that's what it should have. Yeah, look at that. That's not right. Yeah, what the fuck indeed, right? Why does it work for the one before it? Load into X, write it, store X. I mean, unless my emulator is doing it wrong. Because I mean, all I'm doing is I'm reading those 2 bytes, one after another here. Oh, you know what? Just give me a second here. No, yeah, no, it's fine. No, it's good, it's good. There's nothing wrong there. Yeah, so what the hell? No, I mean, I'm literally looking in memory here. All I did, like if we just look at this loop here, we have 2 bytes. We are reading, we have a stack offset of 3. My stack address, which doesn't change, is here. So we compute our variable address. We read the 2 bytes there into this array. And those 2 values are not correct. I mean, it's not what we expect. Yeah. So first, let's simplify. So there's a store X. So since it's the only store X, I should be able to debug this with by just putting a breakpoint in the CPU here. So those are 8-bit stores, and then this is a 16-bit store. So this is what we expect to hit. Let's put a breakpoint in there. Okay, so let's try that. No, ++i and i++. Not, but this happens even before the ++i, right? This is just a storing of the initial value that's wrong. Oh yeah, I gotta run without DAP. Why isn't it hitting my breakpoint? Oh, this, no, I'm attached. Hit my debugger. So this is my command line debugger, in case you're wondering. Not sure why it's not working properly, but what I'm going to do is launch this with the DAP debugger again. I do need to stop. It's starting to get quite late here. But I don't like leaving when there's like a bug like this, because I always end up thinking about it all night until I figure it out. So I'm not hitting my store. Is it because, no. Oh, it's due to inlining. Let me see if I can remedy this. I'm going to disable debug symbols, or basically the optimizations for CPU.cpp, so that hopefully I can step into my inline functions. This would explain why I wasn't hitting my breakpoint before. And now it has the it wants to recompile all my files for some reason. Okay. Also kind of cold. One thing I need to do is I need to upgrade this computer. It's really old and really slow. And I'm starting to really feel it. What is it? I don't think I should tell you. I don't even know. It's like a I don't know, 7-8-year-old i5 with like 12 gigs of RAM. I mean, I've done some choice upgrades over the years to just kind of keep it chugging along. I replaced the originally mechanical hard drive that runs my OS with a SSD, so that helped a lot. I replaced the graphics card with a okay one, but it's like a dual core, like a 2-core dual. So it's like 4 cores, 4 logical cores. So yeah, not great. Yeah, yours sounds a little bit better than mine. Build failed. Oh, right. Oh, this is running? Okay. Okay, so there's the first store. Now the value in D is 51325. What does that correspond to? That's odd. Oh no, that's an address. I'm such an idiot. Okay, so we read that. Is it source register? No, so no, that is the value. No, that is the value, and I'm writing it to some address here. Let's see, the effective address is 51323. C87B. Have I gotten to main yet? So if is that a stack, right? Might be. I haven't debugged this in so long, I'm like forgetting how this works. So AFE4. AF. Oh, okay, so I should be getting this store here. Okay, this is trying to store register D. Okay, so I actually don't care about this one. So let's see, what's this? 8-bit store. Okay. Another store here. So this must be all the stuff from the BIOS. So I'm going to hit a lot of these. Okay, so we know we only care about this AF store here. But how am I going to make sure that it's the one I care about? You know what I'll do? Let's stop this nonsense here. Let's go back to my Vectrex here. We're going to use my instruction level debugger just to validate this. Let's remove all these breakpoints here. And now what I'll do, okay, I'll run it this way, and I need to tell it to break in main at instruction, let's say, break at 009A. Yeah. So I have a file for this where I can tell it what to do when it launches. In here, so stop at 009A. Okay, let's see if this works. Hit F5. Yes, I know, but you don't know. I'm not going to sleep. It's going to keep me up all night unless I solve it. And I might end up having to stop, but... Okay, so here we are. If we trace, we should see instructions that look familiar. So load effective address -2s. There it is. So we are about to do this instruction. All right, so we're about to do the load X here. See, it does know that it's 32,767. So I would be very surprised if that's not what it does here. Let's go back into my CPU and enable this breakpoint. Really, the one I want to enable is here. See, this is my cool instruction debugger. It's really fun. It's been very useful. All right, so let's step this. And how come I didn't hit my breakpoints? Oh no, sorry, that was the load. Here's the store. So now if I hit step, there we go. X 32767. So my effective address is where the stack is. In fact, it's the top of the stack. It looks insanely complex. Cool. Whoops. It's actually not that complex. It's you know, it's a lot like GDB, and it's an instruction level debugger. But I did spend a lot of time on it, so pretty happy with it. Okay, so what am I doing here? I'm writing at CBE 6, and then I'll be writing at CBE 7, right? So those are really the two, at least in this address space, those two where I'll be writing to. I mean, this has to work. All the games work, you know. There's just no point really in thinking that this is the problem. There's something else going on. Anyway, let's just see what it looks like on the stack after I've written to it. So we're going to write the top first, the high first. We're going to shift right by 8. And we're going to write 127 in the top. And after that, we're going to write 255. So those are the 2 bytes we should expect to see. 127 and 255. $127 high and 255 low, which makes sense. In fact, I can even print that value. There's 127 and there's 255. Yeah. Let me try this one more time. So actually I'm catching the store now again. So there's the value, 32767. So, you know, once again, we're getting a write of 127 first. Actually, I should note this down, the address that we're writing at, because I should be computing the same address, the same logical address, that is. So it's let me write this. So when we're writing at this address, we are writing this value. Wait. Let me step in. There we go, 127. Okay, these are the values here. That was some garbage from before. And then the low byte, is like this. Okay. All right, so here we are wanting to print our 3 values. Let me take a look at the current address. Oh yeah, thanks man. I have a bit of experience with it. Been using it for a little while, you could say. I'm about to check. I just want to get right now my stack address. Okay, so there's my stack address. So what does that look like? CBE6. So that's correct, but I'm going to be offsetting from there. Oh, hold on. Wait. Debugger is not helping me very much right now. I'm a bit surprised what I'm seeing here. Oh, no, okay. The reason I'm surprised is because I was expecting the first two variables to be there. Okay, but I removed those. Right. Right. Okay, is that why you're asking, is it still correct? Because now that I've removed those variables, this might be working? It's true, I didn't even think about that. Oh, okay, but anyway, it's possible that now it'll work. So let me see, because the stack is exactly where we expect it to be because there's only one variable. We should be reading 127 and then 255 in this loop here. So right now value has garbage in it, right? So 127, there it is, and then -1. -1. Oh, wait a minute. Oh my gosh, I think is it because, no, I thought I saw something, but damn it. Let me see here. Oh no, it is that. I think it's because I'm doing ++ on it. Right? No, it's not. Because I'm too tired now to think straight. Oh no, okay. So wait, what's going on here? It's 255 is my value here, and yet when I come out and write to value, it says 255. What the? Yeah. Probably, yeah. It's reading, okay. Yeah, that's true. It's uint. I should be storing this as a uint. Does it really matter? It's just the bits that matter. It is 255, but does that matter? Maybe it does matter. Let me think. then we just mem copy it. Let me think. I guess it must be that, right? I think. Why would that matter? Just mem copying the bits. Who cares? Like basically if I reinterpret cast this to a UN16T star of value 65407. There's my bad value. Big little endian. The thing is, I'm dealing with the bytes myself, right? So if it was a byte swap, it would work by just swapping the bytes, but that's not, you know. I'm just not seeing something. So basically the way I did it is I write the low first and then the high in my CPU, you know? So it's, oh no, sorry, it was high first and then low, right? Is that what we said? So 127 should be the high. Oh, okay, that's true. So it would be this. But see, that still gives, oh wait, and then what, 255? Oh, there it is, the value. Yeah, you're right. I did have 127 twice. You have good eyes, man. You can see that in this tiny font here. So, okay. So that means that I need 255 first. So it is endianness. Okay, it is endianness. Okay, so it is because... But then why did it work for that other example? Was it just bad luck that I chose like the one example for which endianness didn't matter? I suppose that's what it was. Okay, let me try and do the endianness read backwards here. Yeah, the other example strangely worked. But even if it wasn't signed, it doesn't matter. Endianness would still matter. It really just was probably a bad luck. This case right here, probably because it stores the same 2 bytes. That's what it is. Yeah, exactly. It's like the one case I could have tested that would not have like shown me the endianness problem. Massive face palm there. Oh man. All right, so let's see. Let's just go for gold because we know it's going to work, right? Take this out. No! My fix is not right. What did I do? Oh yeah, it's like this. I hate the loop backwards with unsigned types. It's tricky to get it right, you know. This is like the sort of like the trick to do it. It's ugly, but it works. Otherwise, I have to do the thing of like making this like a signed type so that it can go to my, you know, so you can detect that it goes to 0 and becomes less. It's always really a pain. But this little trick where you make the condition do I minus minus greater than 0, it actually works out and it keeps everything with the right types. Not a huge fan, but it works. So let's see now if it works. And there it is. Holy moly. Hey man, you got good eyes though. You saw my mistake in the tiny font of my debugger. You must have a really large screen or something. Because man, I can barely read it. Alright, 1 o'clock. I think it's time for me to stop. But this was pretty cool. Next time I'll try a whole slew of data types and all that. But yeah man, thanks for hanging out and thanks for watching guys, and I'll catch you next time.